Hey guys, welcome back. I was asked a few questions about electrical work, and it's things I hadn't showed before, and somebody had asked and wanted to see some of this stuff. So I figured we're putting a sunbeam together today in Model 9, and on this one here, this coil really doesn't need anything, but I want to extend the leads on it anyways. So normally I just take them back to about here, and I will add extend a lead to it. But this one I'll take back a little bit further, and the one question I was asked was, is this the same wire that's wrapped around the coil on here underneath this wrapping? And no, this is not. This is a thicker wire. If you can see, this is a stranded wire. Right there, you can see that's a stranded wire, and that's not what's wrapped around this coil. This is a single coated wire around there. It's got like a resin coating on it that's wrapped around this coil, and then it's attached under the coil. It's attached to this wire is attached to that single wire, and then it's wrapped up in the coil. You can see here it's wrapped up in there. So if this broke off or was brittle all the way down to where it attaches to the coil here, then basically what I have to do is take this tie off right here. This got a piece of cloth that basically holds this in place on this coil, and you have to take this coil off right here, or if you're doing the other lead, you'd have to take this coil off, or if you're doing both, you got to take both your coils off, and then you got to go and unwrap it until you find where this lead right here ties into the lead coming off of the coil. And these coils have, if you can see, you've got your line that comes in from the cord, goes into the coil, and on this one right here it comes back out here to then it connects to the brush holder. Alright, and it goes through the brush holder here, and it comes over here. Yeah, it comes over here to the switch. After it goes through the brush holder, it'll come over here to your switch, and then it goes back into the coil, and it comes back out and hooks to the other side of your cord. So at one point, all this coil right here is energized. It's just there's no current flowing through it with the switch in the open position, obviously. But anyways, what I'm going to do now is I'm going to go ahead and I'm just going to extend these leads. I'm going to cut them back to here, and you can see these leads are nice and pliable. A lot of times what I'll find is they'll be nice and pliable down here, but you get up here and they're stiff, and you try to bend them and they'll just crack on you. These aren't like that, but I got to extend them anyway, so I'm just going to extend them down a little bit further, and just to show what I would typically do on extending these leads out. Now I'll just take them back to about here, and then I want to just strip the coating off just enough to where I can attach new coating to it, or the new piece of wire to it. So you just expose the inner wire. Alright, now I've got the inner wire exposed. I'm going to grab my new leads that I'm going to extend it with. I just want to strip these back. Alright, and then just going to connect them together here. And there's I don't know, I think a lot of people solder differently. They'll connect their wires differently. I just overlap them about halfway on each other, and then just twist them together like that. And then it should be nice and tight on there. And at that point, I go ahead and solder that up. I try to get a little flux on there, because you want some dirt on that wire, especially that cloth one. So use the flux to clean it up. Just make sure you get it soldered up really good. That's a nice joint. And you can move on to the next one. And just make sure you got like no sharp pieces of wire sticking up. Make sure everything's twisted nice and flat. Same deal, we'll put a little bit of flux on it there. My depth perception seems to be a little off today. There we go. There. Alright, so now that that's soldered up, we want to cover that up. So we're just going to spit it out. We're going to slip some heat shrink tubing over it. And I like to go all the way down to the coil with it there, because that's the older cloth stuff, so you know, better protection for it. Alright, and then there's several ways you can do it. You can use a torch or you can use a lighter. You know, I just take the heat from soldering iron because basically all you need is heat on here to shrink this, so it doesn't matter where your heat comes from. You can use a heat gun, whatever. Alright, now at this point, these leads are too long. I'll just trim them to length after I get everything on. But let me shut all this down here. And now we can do a little testing on our coil as well. A lot of times, you know, if you have a bad coil, it can throw you when you're trying to figure out what's wrong with the machine. So one of the easiest things to do is to just check your coil. Alright, so as we know, you know, you've got power goes into one of these leads, goes through the coil, comes out to the brush holder, and then that makes a contact across the commutator on the armature to the other brush holder, goes out to the switch, where it goes through the switch when the switch is closed, and then back out to the neutral side of the cord. So what we want to do, and you know, I've also been asked, you know, about, you know, do these have to be, is one of these a hot wire? Does it have to be polarized? No, it doesn't, because you know it'll run no matter which way you have the plug hooked up. And if you think about it, when these were made, there was no polarized plugs, so you could, no matter, you could take your plug and you could plug it in either direction into an outlet. You never always plugged in the same way twice, so it's you know, it's irregardless. Even if you put a polarized plug on it, it doesn't matter which end you hook it up to here, because basically what you're doing when you take your plug out of the outlet, you know, your non-polarized plug, if you plug it in differently next time, it's essentially the same thing as just switching these wires. So you know, it makes no difference on the way the machine runs. So there's really no difference in that. The other thing, you know, we always want to check is make sure these wires are nice and pliable and not cracking. You know, same with these back here. And these always seem to be pretty good too. A lot of times, I mean, the coating on these is good. A lot of times this coating gets really hard. You know, you have to deal with that. So to check the coil, I think I'm just going to hook these two together here. You know, we'll make our connection. We'll simulate. I don't have any clips out here right now, but we'll simulate our connection across the commutator, and we'll also we'll also simulate our switch being closed back here. Alright, so now with all that connected, we just want to check the resistance. Let's see, can you guys see that? Probably. We want to check the resistance across our coils, and if we have a bad reading on here, then we can try and isolate which coil it is. But alright, okay, so I'm not making a good contact across here, and I should just go find my clips, but I feel like heading out there. Let's see if I can just get this together a little bit better here. Alright. Alright, this is a bad example, but anywho. Alright, you know what? We're going to check these coils individually just because I can't get those to stay together good. So with our, our switch is still closed, but it doesn't matter. On one coil where you've got your lead, the same coil where the brush holder comes out, go through and check your coil, and that's showing 2.4 ohms, give or take, which is low resistance, which is what you want. I mean, if you saw something high like 50 ohms or something like that, or if you saw that it was open, then you know you've got a bad coil on there. And this one should be approximately the same. As you see, that's 2.4 ohms as well. So both our coils have the same resistance. They're both really low resistance, which is what you want, because you do have a length of wire wrapped around there, and anytime you've got a length of wire, you do have some resistance, so you got to keep that in mind. You're just looking for a low resistance reading, and if you add those two together, we probably would have been about 4 ohms through the whole thing, 4 or 5 ohms through the whole coil. So this coil is good, and we just verified that by testing it. Now the armature, I know there's I'm not going to check this entire armature because I don't suspect it being bad, but I'll give you an idea of how to check it. And this armature hasn't been clean, polished, nothing. We've done nothing with it yet. But this is how you can find out if you've got a broken wire on here, or if you got wires shorted. Same thing. You want to, set your reading on ohms, and you want to go to two of these bars on a commutator, 180 degrees across from each other. And you can see we're showing 6.7 ohms. And then you want to go again, check the one next to that, 7.1. 7.0, and you want to check all of them, 180 degrees across, so you basically have to rotate this thing halfway. But you want to look for, and you're looking for low resistance as well. So you're going to have a little more resistance than you will on these coils, but you still don't want high resistance on there. And you basically, every coil is different, so there's really no number that you're looking for. You just want to look for consistency across all your bars. You want to be within the same range. If you find one that's extremely high or one that's open, then one of these isn't connected to this coil, or the coil that connects to that commutator has a bad connection in it. The other thing you can check too is check for shorts between your commutators on here. So you basically check in between you're still looking for very low resistance in between them. And as you go out, your resistance should increase slightly. And you see now it's up to 3.3. But you can go through and you can check, all your ones that are next to each other and make sure that you don't have a short on there. Because you can have one, that's shorted to the one next to it, whether it's got, something got lodged in here, something metallic got lodged in here or whatever. But that's another thing that you want to check for too. And then after you got your coil tested, then or your armature tested, then all the coils in there are good. At that point, you can put everything back together. And if you have an issue, it can be isolated somewhere else. Another thing is these resistors here. So you want to make sure that you've got a clean spot on it with bare metal showing, because you're not going to get an accurate reading, or if any reading, through the crap that's on there. like this resistor here. Isn't showing anything, so that means I'm set at 200 ohms, which means it may be out of range. It may be over 200 ohms. So I'm going to go 2000 ohm range on here, and we're going to check it again. And as you can see, as soon as I get it connected good there, we're over 200 ohms, so we're bouncing around, you know, between 230 and 250, depending on where it's at on here. And that's not due to the corrosion on there, because I'm on a spot of bare metal on both sides of it. And you can see, I mean, it's way out of range. It's about 250 something. But if I were to go back on here on bare metal, you know, you can go right on these wires on here, and you can watch your resistance increase as you move it along there. It becomes almost like a variable resistor, which it is basically the same. If all your wire is exposed, this is a variable resistor. So I could probably, technically, I could probably come to about here. Cut the wire, reattach it here, and it's going to be a 180 ohm resistor again. But if it's reading that high now, I get the suspicion that it won't take long before even that starts reading high or burns out. That just means it's a resistor in decline. You know, it's deteriorating, getting old, and it's time to replace it. But since we can't really replace it because we can't find replacements for these anymore, I go ahead and I rebuild these. And basically, I just got to take one of these caps off. You know, these have little clips all the way around them. The older ones have just 3 clips, or the newer ones, I should say, have just 3 clips that bend over and hold it on. But if you can go through and get them disconnected, you can go through and pop it right off. Alright, now at that point you could just cut the wire and prep it for a new resistor, but I like to just take all this old stuff off of here just because it's just going to end up crumbling off eventually anyways. So I go through and I just peel it all off. And you gotta be careful because this wire is sharp and it'll slice you. Alright, we have all the wire off of here. I just got to take this cap off this end of it. And when these were new, you know, and this wire was new, this length of wire, they had figured out this length of wire is 180 ohms resistance through this nichrome wire. You know, I don't know if it's corrosion. I really don't know what would make it read much higher. I don't know if it's starting to burn out or what. But anyways, we don't have to deal with that. Alright, so now that we've got this all stripped, we need to drill a hole in our end cap on here. Alright, there we go. You can see we've got a little hole drilled in that. This one here is going to be a little trickier because it's not attached anymore. So we're just going to hold it with something. Alright, obviously I grabbed a worn out drill bit here, so I should probably set that aside and throw it out so I don't grab it again. Normally, you know, with a good drill bit you can drill right through that. Alright, so next step is to grab our replacement one. And these are wire wound resistors. They're smaller, but they're 180 ohm, 5 watt wire wound resistors, and you can find these, lots of places online. But just make sure we're going to verify, just to make sure that it's good, because we don't want to go through all this and have to take it apart again. So I want to verify that the resistor reads correctly. And you have 180, 179. So we have a good resistor. And we're just going to slip it inside the tube here so you can see the lead comes out the other end there. And we'll put this cap on the other side. And it'll pop on there, but I'm not going to crimp these down yet. I'll wait till we get this soldered on. And you kind of just center it in there. And let me find my silver solder. Alright, well, I was soldering something up in the garage, obviously, but here we've got high temp silver bearing solder. That's what you want to use on this, because if you use just a regular regular solder, lead solder, whatever, these things get incredibly hot. They don't get they run no cooler than the original resistors on here, which we all know how hot they get when they run. So it'll actually melt off your solder, and the lower the speed that you're running at, if you have your speed set too low, your resistor gets even hotter yet. That's why it's always crucial to not have your mixer speed set too low on these sunbeams, because that resistor just gets extremely hot and will burn up. But on here, I got to be really careful as well, and just make sure that these aren't allowed to get too hot, because it'll eventually burn up, and if you get it too hot, it'll actually melt even this solder right off of here. So that's why I use this high temp silver bearing solder. And I did one of these in my Model 7, and before I used it or even finished it, I put it on. I turned the speed down really low, way lower than it should be, and I ran that thing for almost an hour. And I didn't have it in the case either, but I did see that resistor was almost getting cherry in the center, so I shut it down after almost an hour and let it cool, and then I checked it, and it was right back where it started. I think that one was like 180, 181 ohms, something like that, and it was exactly where it started once it cooled down. And I've been using it ever since. I mean, it just keeps running good. So I do have quite a bit of faith in these here. I think more so than if it were, like I said, if it were cutting the wires back and shortening them when they read too high. I'm just trying to fill this hole here with solder and make sure it's adhered good to this brass on here, which I cleaned off with a wire wheel. There we go. Alright, that one's good. Now, get this other end soldered up here. And no, I'm not using flux on this either, because I did use flux on it before, but I found I had to run the machine for a while to get it to stop smoking, to burn off all the flux. So this is just a lot easier. The only smoke that'll come off of this when I first run it, which I usually burn them in before I send them back, but the only smoke that'll come off will be just oils from my fingers or whatever on here, and it only smokes for a little bit and then it completely stops. Alright, I get a little more solder on that there. When I go get more drill bits, I'm going to get a size or two smaller, so I don't have as big of a hole to fill for these. But you definitely want to get the brass hot enough so the brass actually melts the solder too, and that way your solder will stick to the brass when it's cool. There. Alright, that side's done too. Alright, so that's that's what I do. Oops. That's what I do when I rebuild a resistor, and then all I gotta do at this point is just clip these ends flush right here, and then it'll pop right in just like the original did. And then I gotta go through and just bend these tabs down so they're not sticking out like that. But let's go through and just make sure that we're still 180 ohm resistor here. There we are, right at 180. So this resistor is good to go for this machine. Alright, now another thing is these capacitors on here. There's really not any way I know of to really tell if they're good or not, other than if they run constantly at high speed, they're dead shorted, which you can tell by if you were to put a multimeter on it like this, and you can check for dead short. If it was dead short, it would do this. Your gauge would do that. This one obviously doesn't have a dead short in it. But we can, when we're checking it like this, you're actually running a small current through there. So I believe I can go over here and now check and see if that current is in there. Okay, let me do this again. I slipped off. And we're going to run a small current through here. I don't know which one uses more of current. And we're going to set it here, and we're going to check and see what that meter goes to. Okay, I thought there was a way to maybe not, I don't know. Unless you got an expensive meter that can test capacitors, there's really no other way to test them. If the capacitor's got a dead short, the meter will show you, and it'll run on high only when you turn it on. If it's just a bad capacitor, not a dead short, but it's just failed inside, it'll run a lot rougher, and you'll see arcing. So when you have it apart and you run it at a low speed, you'll see a lot of arcing. These kinds here that got the cap on the back of them, that covers everything up. It's hard to run them like that because there's no way you can get it at low speed. But if you put that cap on and then run it at low speed and listen for the arcing, and on machines that are open, you'll actually see the arcing in it, and that's a good sign it's time to replace. And it's always a good idea to have another capacitor on hand. In case you got a bad one, or you're not sure if it's bad, you can pop in a good one to check it and compare it to the other one. That way you'll know if you got a good capacitor or not. You can get those from davesrepair.com. He sells brand new capacitors that he made, and I've used them before. As a matter of fact, I got to restock on them because I'm all out right now. But anyways, I think I've covered most of the questions. I think there was another question that somebody asked about. Why do I do the ground lead up to here? Because this is a good spot to ground it, because it's a solid. You got a solid screw in there. You can connect your wire there. The wire's out of the way, and they're saying something about it being more of a pain to run through here. But as you can see, the size of this opening here, there was something that as big around as this was in there. It was that RF filter. And it had two thick wire leads on it. So to run a ground wire from here through there, where that used to be, is not a big deal. There's all kinds of room, and you can just fit it through there and hook up your ground. And that's the reason why I do it. You can ground it anywhere you want. If you ground it here, you can see on this one here, this is powder coated for one. So you're not going to get wire down into bare metal. It'll be sitting on powder coating. And the other thing is, if you try to wrap your wire on here and have this screw hold it on for your cover, you don't know if that wire slips off of there or not. Once you put your cover on, you have no way of knowing if that wire pops off of there or not. So this is a good place to hook it, where you can tell that it's securely fastened when you put the gearbox cover on. So anyways, I hope that covers anything. If you guys have any other questions or comments about this electrical stuff, let me know. I'll try and answer those. I try to cover everything here that I know I've been asked about on this stuff. And this relates to sunbeams. in particular on this one, but checking your coils and your armature, it's the same on any of these, anything with an electric motor in it like this, it's the same way. So hopefully that'll help you out and that'll cover everything. But anyways, like I said, if you do have questions, just ask me down below, and I'll try and get to those as soon as I can. Hopefully I can answer them for you. But anyways, we got more videos coming up. We got to put this sunbeam together now. So I guess we'll see you on the next one. Thanks.